Electronic and magnetic properties of graphene quantum dots doped with alkali metals. In this work, the magnetic and electronic properties of armchair hexagonal and zigzag triangular graphene quantum dots doped with alkali metals are investigated using DFT. From the results, the calculated positive binding energy implies that all the resultant structures are stable. The geometrical shape, electronic, and magnetic properties of a hex and Z-tri are slightly affected by attaching alkali metals to their edges, while in case of doping the structures experience noticeable alternations. With respect to shape, the flake deformation due to doping is higher than the case of edge functionalization, leading to a decrease in the binding energy. The bilayer systems have comparable binding energy between the layers that can be enhanced by doping due to the strong bonds formation between atoms from both layers. The density of states shows that the HOMO-LUMO energy gap substantially affected by the type and position of the doped metal. The energy gap significantly affected by doping, for instance, the gap decreases from 3.7 electron voltae in hexagonal flakes to 1.5 electron voltae when it is doped with sodium in the upper position. The found enhanced spin polarization, in addition to the tunable magnetic properties, makes doped graphene flakes promising candidates for spintronic devices. The broken bonds around the doped metal form molecular orbitals with electrons loosely bound to the flake, thus decrease the energy gap. This conclusion is supported by the HOMO/LUMO distribution around the alkali atoms in all the cases. On the other hand, the HOMO/LUMO energy gap increases in pristine BZTRI due to the passivation of the interactive edge states by each other from both the layers. The magnetic properties show a significant diversity depending on the shape, dopant, and the stacking. The spin calculations show that the lowest ground state energy for armchair hexagonal is the singlet spin unpolarized state. Substitutional doping converts the non-magnetic armchair hexagonal to ferromagnetic with total spin of 1.5 originated from the unpaired electrons of the alkali metal and neighbor C atoms, or 0.5 from only the dopant. The optimized spin state of zigzag triangular is the quintet state due to the presence of edge states in triangular flakes with zigzag edges. That spin state can be increased or decreased by doping depending also on the strength of the interactions among the flake atoms. Thus, zigzag triangular with 46 carbon atoms have a ferromagnetic state with total spin of 2 that increases to 2.5 or, in few cases, decreases to 1.5 by doping with 1 alkali atom. Thus, the significant enhancement of the spin polarization and the tunable magnetic properties make doped graphene quantum dots interesting for spintronic devices.